Hey, this is Mayor from Chat with Data, and in today's video, I'm going to be talking about how to chat with a long PDF. So here we have a 56-page legal document. It's actually a legal case for a massive Supreme Court case in the United States. You can see we got tons of pages, which is typical for most PDF documents. And you can see it's this kind of horrible text that you can't even properly copy out as well. So what we want to end up with is a situation where we can chat with the document. So we can say, what is this legal case about? Press enter, and hopefully we'll get a response back. This legal case is about student Frederick. Interesting. Now we also have sources referring back to the PDF, but also sections of the PDF as well that you can review. So maybe you don't understand something from the response, so you can say back, what do you mean by qualified immunity? And let's see what comes back. So is this kind of back and forth interaction where we're using LangChain and the GPT-4 to get a response back that hopefully is what we're looking for. Interesting. Cool. Let's check that. Points to actual links. And so that's pretty cool, right? So you get the references and you also have sources as well inside the document. Cool. So how do we do this? How does this work? Well, let's jump into the diagram and get started. So this is the PDF chatbot architecture using LangChain and GPT-4. Now, when I show the code, or if you want to replicate from the code base, just bear in mind that you can swap out to older models. You don't have to use GPT-4. I'm just lucky and was lucky to get access to the API. So we have the PDF documents. We convert it to text, right? Then we split the text into chunks because of the issue of context window. Remember, with if you've ever played with ChatGPT, if you try and paste an entire PDF doc inside, or you try and copy the text and paste it inside, you probably notice that it says that the size is too big. So we overcome that issue using LangChain to split into chunks. And each chunk is going to be a certain number of characters of your text. So maybe it's 1,000 characters, 2,000, whatever the case is. So we have these chunks and we create these embeddings. So an embedding is just a number representation of your text. We store it somewhere. Okay. So you can kind of think of this as an ingestion phase, right? We'll talk about that in a second when we jump into the code. But this ingestion phase will take this document, convert it to text, split it, and convert it into numbers that will be stored in a vector base. And in this case, we're using Pinecone. So I'll come back to that in a second. So that's phase one. Now, phase two is from your front end, the user asks a question. So maybe they say, how do I create an account? And what you've done here is PDF docs of your company's support docs, right? So the user says, how do I create an account? You combine that with the chat history, as in this case. You send it to the large language model, so GPT 3.5 or 4. And you say, hey, create a standalone question. So based on the chat history and the new question, create a standalone question. This standalone question we convert into embeddings. So embeddings kind of look like this, right? It's, if I just do a quick sketch, you would just have something like 0.1, 0.2, 1.1, and each vector, you would end up with 1,500 and 36 of these in the case of OpenAI to represent the text, this standalone question. And so all these vectors are then taken to the vector store. So it says, hey, okay, these are the numbers I have. Let me compare to the numbers you have. And remember, when you stored here, each of these represented these vectors, right? And they all had different values. So what it's going to do is check and see, okay, which chunk is similar or most similar, or which chunks are most similar to the question, this standalone question that was asked, right? And so it looks to the relevant documents that are embedded. It retrieves the relevant documents, which are here, in these cases, the source documents. Then it combines the standalone question. So in this case, whatever this plus this led to that. And it uses the relevant docs as a context to say, hey, based on this standalone question and the relevant docs, do X, Y, Z, right? You obviously customize what you want the model to do. And then GPT-4, in my case, returns an answer. And that's basically what we're seeing here, right? The response comes back. So that's the architecture in a nutshell. So let's jump into the code itself to make sense of what's going on. Cool. So basically, there's two phases involved. We already spoke about the ingesting phase, which is just the phase of effectively converting your PDF into these vector numbers that will be stored in a vector store. So if you can see what's going on conceptually, we've gone over the high level. So LangChain has this thing called a PDF loader. And what the PDF loader does is it takes a file path. So in this case, the PDF is in here. So this is the file path. And what it does is it basically loads the raw documents from the PDF file. So it does all of that for you under the hood. So these raw documents are just basically the text, contains the text of the PDF. Once we have that, we split. Remember the splitting in the diagram into chunks of 1,000, and they overlap. So one section to another of 200. And again, this is provided by LangChain to make this easier. So we split the docs, and then we create the OpenAI embeddings function. Remember, we need we need this thing that's going to help to create the numbers from the text. And so then we create or initialize this index for Pinecone. So an index is, you can think of as the name of your store, or where you're going to store your vectors. Then we run this from documents function, which effectively what it does is actually goes through the process of taking the embeddings and putting them into creating the embeddings and then putting them into Pinecone, right? So that's the namespace here. So you can change this namespace. Well, actually, in the configurations, you would need to, because when you create Pinecone, you would give your index a name, and you would also give it, you have an optional namespace. Why I recommend that, because you probably want to have a way to categorize different vectors, different embeddings that you make into the store. I'm going to show you what that looks like. I know it might sound very opaque right now. So yeah, there we go. So you have your index, which is Pinecone. You have your documents, which are split already. You create the embeddings, and you store in the namespace, right? So let me run this again, but I will change the namespace so I don't override what I currently have. Let me just call this demo. I'll just show you what that looks like. So there's a script in package.json that is called ingest, and that script will run this function, right? So let's npm run ingest. I just want you to see what actually happens here. There we go. It's creating the vector store, so it's done the splits, it gets the metadata. Now it's creating the vector store and ingestion complete, right? So that was this process. Now the embeddings were done and the ingestion is complete, right? Because we run. So let's go into Pinecone and see what that looks like. So this is my Pinecone dashboard. You can set this up on your own and create your own index name. So like I said, you think of it as storage. You set your environment. So your environment is basically where it's going to be served closest to, and you want to make sure this matches what's on your code. Cosine is the calculation that's done to find what's similar, and then these are the dimensions for each vector as I spoke about. So you would effectively have, say, index here. So if you check it out, look at, we did demo, right? And that was what we just did right now. And demo has 178 vectors, which is the same as GPT-4 PDF. Let me show you what a test looks like. Should query. So this is what a vector looks like. These are empty, but effectively you would just literally have these array of numbers, and they represent a particular section, so your chunk that you've put in. And so when we say 178 vectors, that's what we're referring to in this case. So that's basically Pinecone in a nutshell. Let me see if I can test retrieve one. D1. Oh, there we go. So this is an example of what the vectors would look like. So every vector has an ID, and you can see it has an ID, it has values, it also has metadata, which is text. So you can kind of think of this as your chunk, and your chunk is represented by these values, these vectors, right? And it's these vectors that are compared to the question the user asked to then say, hey, which one of you guys is the most relevant to the question? So I hope that explains Pinecone, and obviously you've seen now. Cool. So yeah, back to the code. Basically, now you've done the ingestion, so that's phase one complete. So what's next? Well, pretty much at this point, let's just go through other things. So this is the Pinecone, initiating the Pinecone. So here you set your environment as discussed. You set your API keys, so you make sure you clone this one, and then you create an environment variable folder where you put in the examples inside, right? So you copy these, and then you put it in here, and then you go to OpenAI, you go to Pinecone to get the API keys, right? Cool. The visual guide is also in here. This is the OpenAI client, which you can get from LangChain directly, but I'm just trying to make this more structured. And then we have MakeChain. So MakeChain, effectively, what's going on here is this is the streaming effect that you saw. And in this streaming effect, this is actually a custom chain. So usually LangChain, you have this thing called a chat vector DBQA chain. And all it does basically in a nutshell is it takes the question and it goes through the flow that we showed in the diagram, and it goes to retrieve the similar documents and responds back when you call the chain, right? So it's a chain. You can think of it as a series of actions, just like you saw in the diagram. So here we're passing in the vector store, which is Pinecone, and then we've just got some custom prompts, and we're saying return the source documents to true. So that's how we get the ability to see the source documents. And then k is equal to 2, so how many source documents to return. And so this is the streaming effect. It's optional, you don't have to. But here, this is the model name, and you can change this to whatever you currently have access to. So it could be 3.5 Turbo or DaVinci. So it's whatever model you have access to. Temperature is 0 to just prevent randomness in response, especially when it comes to legal stuff. You don't want too much creativity. Streaming, you got a callback manager as well, which handles the tokens that are being streamed back. And that's that side. So let's go to the front end. Cool. Okay, so there's quite a bit going on. I've received quite a bit of requests, quite a lot of requests to do a step-by-step tutorial, especially for people who are new to JavaScript or beginners in coding. So if you check the description of this video, there'll just be a link to a waiting list, so you can go sign up if you're interested in that. But I'll try my best in the short time I have now to just kind of go over what's going on. So this is the front end. Obviously, we're dealing with the query. So this is the question, and we have a state to manage the source documents coming back. And as you can see, we have, an initial state. Basically, messages is the messages, pending is messages that are coming in, and history is your chat history. So again, we're trying to represent the diagram I showed in code form. Let me skip forward. So yeah, this is a submission. So obviously we clean up the query because maybe the user has spaces in their question, so we trim it up. And then we set the initial state to effectively take into account what the previous state was, and also the user's question as well. So that's all passed into the messages, and then pending is then defined, right? So now we have the new state and the messages and the type of question. It's a user message that's coming through, right? We start loading, and then we set pending to an empty string, all right? So at this point, what happens is we then hit the endpoint API chat. So if I jump in, receive the question, the history, sanitize it just to clean it up, to make sure that it's good for embeddings. And then with Pinecone, we basically go into Pinecone to say, hey, let's create this vector store where we basically have the embeddings and the namespace, and also this index represents the index name as well. And then what we do is we just create this function to tell the client, tell the front end that, look, data is coming, we're going to send data to the front end, and this function is here. Now, what happens effectively is that when this chain function is called, right, as you can see, it in the previous code I showed you, it uses the chat vector DB QA chain, which what it does is it goes, retrieves similar documents, comes back, and you saw that we set the stream in with the tokens, right? So what's going to happen is it's going to take this vector store, go do the search, and then retrieve the tokens. So the token is just like one string, per string, and per string is going to send that string to the front end, and that's how you get that stream in effect. So this is a callback function for that we created that would effectively, every time a token would come, send it to the front end. So that's what's going on there. And so this is where we call the function. So we're calling this LangChain function with the sanitized question and the chat history. Again, matches the diagram that we spoke about. And then we also send the source documents, which we set to true. So now the source documents have come back. So response.source documents, which is coming back from our set in return source documents, we send that to the client as well. And that's how you're able to see what the source documents are. And when all of this is done is triggered. And that's why you can see what's going on here. When it's done, we set the history. We also set the messages, and we call off the loading, right? Because at this point, there's no pending source documents. So we just basically say, hey, here's the API message, and it's state.pending, which represents the message that came in, and then the source documents come in. Otherwise, if it's not done, we just pass the data that's coming in, right? And so obviously here we're just checking for the source document before we set the state with the source documents. So if what I'm saying sounds like gibberish, okay, yeah, we also use memo to effectively memorize this, and because it's a function we're calling over and over again. So we're just trying to be more efficient here. Now, obviously, this is the front end that captures all of that, maps over it, and so on and so forth. So I don't, because of limited time, that's just the overview. The source code is going to be available. Like I said, the visual guide is here as well. But yeah, I think there's been quite a lot of requests for more in-depth step-by-step. So if you're interested in that, check the description, join the wait list for potential workshop. I'll just talk to people on the wait list and see if there's enough demand, then I will do a comprehensive workshop step-by-step on how to build a chatbot for your document. So whether it's a PDF, or it's a book, or it's multiple PDFs, or it's a docx or an Excel, or whatever. By the end of that, hopefully you'll be able to build an application for yourself or your clients or whoever to have a back and forth interaction with that. So this is it in a nutshell. If you have any questions, just shoot me a message on the comments. And yeah, thanks for watching. Cheers.